Hey everybody, welcome to your lesson on research methods and experimental design. We're going to start off with a little quick exercise. True or false? Vitamin C prevents the common cold. We only use 10% of our brain. And the more we're around someone, the more they get on our nerves. Why we need science-based answers. Did you answer true to those common sense statements? Repetition of statements makes them easier to remember and more true seeming. Research helps us overturn popular ideas. Just because you've heard something many times, it doesn't mean it's true. There's nothing to actually write for this. This is just a really nice introduction to why we have different research methods and experimental design in psychology. So there are three main roadblocks to critical thinking. This is where your notes start. They're hindsight bias, overconfidence, and perceiving patterns in random events. Hindsight bias. Life is lived forwards but understood backwards. That quote will make sense in just a second. And this is the BP oil spill in 2010. That's what that picture's of. So hindsight bias is the tendency to believe after learning an outcome that we would have foreseen it. For example, BP employees took shortcuts, ignored warning signs, without intending to harm the environment or their company's reputation. After the resulting Gulf oil spill, which was a huge disaster, with the benefit of 2020 hindsight, the foolishness of those judgments became obvious. So, some examples of hindsight bias. Things like, oh, we knew it all along. After a couple breaks up, friends say, oh, they were never a good match anyways. Thinking critically, why didn't someone tell the couple they were a poor match while they were dating? Were they really a poor match? What would we say if the couple went on to get married? Would we then say, oh, they are perfect together? Another example of hindsight bias, things like we knew it all along. After we lose the Friday night football game, fans say, that stupid move by the coach lost us the championship. We knew it all along. Or it can be a positive thing. After we win the Friday night football game, fans might say, that gutsy move by the coach was a great call. Okay, so we're going to move on to another part. Quick little exercise. We're not going to start a timer, but I want you to see about how long it takes you to unscramble these anagrams. Write down your times, and we'll come back to this in a couple minutes. Okay, the next one, overconfidence. What is overconfidence? Well, it's just what it sounds like. In a lot of these terms in psychology, a lot of them, they define themselves. So overconfidence is the tendency to think we know more than we do. So when I said, oh, it's about 600 new terms in psychology, remember a lot of them will define themselves. So it's not something to freak out about. So let's look at the research on overconfidence. Solution time without answers given and solution time estimate with answers given. The average problem solver spends about 3 minutes on that anagram, those 3 words that I asked you to unscramble. The estimate of how long it might have taken is about 10 minutes. So how long did it take you to unscramble those anagrams? Did your times match up with what researchers found? Why do you think subjects estimated a much shorter time when they could also see the answers? How does this demonstrate overconfidence? So examples of overconfidence, British expert group evaluating the invention of the telephone. The telephone may be appropriate for our American cousins, but not here because we have an adequate supply of messenger boys. Popular Mechanics 1949, computers in the future may weigh no more than 1.5 tons. And of course, there's tons of other examples of overconfidence. So we're going to look at a little bit more research, percent confidence and percent correct. The degree of confidence expressed by experts regarding 27,000 outcomes in world events. That is the 80% of experts expressed confidence regarding 27,000 outcomes in world events. However, the amount of time those predictions that those experts made were correct was only 40%. So overconfidence has a huge impact on our outcomes in world events. But really, only 40% of the time are those predictions correct. So it's really important. Okay, let's do another example, another quick little thing. If you flip a coin 6 times, which of the following sequences of heads and tails is most likely? Don't actually do it. Just record your response and let's see what science has to say about it. Okay, so most people believe that heads, tails, tails, heads, tails, heads is most likely. Why? Well, a couple of reasons. The answer is actually all three are equally likely or unlikely. And some explanations. Random sequences often don't look random. Fraud experts can detect embezzlers who are trying to make their withdrawals look random. With a large enough sample, any outrageous thing is likely to happen. Go back to this because it goes back to the coin flip. When we're prone to perceive patterns, then we're going to try and see patterns where there might not otherwise be patterns. Okay, moving on to scientific method. So you have been exposed to scientific method for many years in science classes, and we're going to look at it through the lens of psychology. And so psychologists use the scientific method to support their scientific attitude. So it's a self-correcting process using observation and analysis to evaluate ideas. That part's not any different. So we're going to start with theories and hypothesis. So what's a theory? A theory is an explanation using an integrated set of principles that organizes observations and predicts behaviors or events. And when you're writing your notes, remember you do not need to write every single word. In fact, in a college level course, if I were lecturing this, you would be expected to keep up with my speed of speaking, which is very hard. And if you try to write down everything, you will miss everything that's important. So it's a really great skill to learn, picking out what's most important and shortening it so that you're really getting down to what's most meaningful. So, for instance, if we observe over and over that a classmate who gets plenty of sleep is usually the one with the right answer, then we're going to form a principle that sleep must improve memory. What theories do you have about some common things like how exercise relates to stress, the way caffeine impacts memory, how smiling impacts mood? And how does a hypothesis advance science? So a hypothesis is a testable prediction. It's often implied by a theory. So for instance, to test our theory of sleep's effect on memory, our hypothesis might be that when sleep deprived, people will remember less from the day before. Or if we want to put it in an if-then statement, if one does not get a lot of sleep, then one will not remember as much from the day before. So, difference between a theory and a hypothesis. A theory uses our observations to explain behavior, whereas a hypothesis makes predictions about the behavior that can be tested. So remember psychology, we're really focusing on behaviors and why and differences. So what comes next from theory to hypothesis to research? Remember, the rat is always right. The rat is always right is something we'll come back to in psychology time and time again. The results of our experiment will either support our theory or lead us to revise it or reject it. So let's consider the hypothesis. When sleep deprived, people will remember less from the day before. What do we mean by sleep deprived? So it's really important to get super specific in psychology because this could mean anything. Does it mean 2 hours fewer than usual? What does usual mean? Does it mean no sleep at all for a week? How will we know someone remembers less? Less than what? Less than whom? We have to use something called operational definitions. This is huge and it's all over the AP Psych exam. So go ahead and highlight this, put stars around it. Not that the other stuff wasn't important, but this is really foundational to understanding what's to come as far as experimental design goes. So an operational definition is a carefully worded statement of the exact procedures or operations used in a research study. For example, human intelligence may be operationally defined as what an intelligence test measures. The variable would then need to be quantified. So in this instance, human intelligence would be the score on an intelligence test. So with an operational definition, you really want, what you're doing is you're making it very specific and quantifiable. So what's an operational definition for our hypothesis? If we've got sleep deprived, we'll define that as 2 fewer hours than the subject's normal amount of sleep. So we're being very specific with normal amount of sleep because we know everybody's normal amount of sleep differs. So being very specific, saying the subjects. And we've got the number 2 in there, quantity. What do we mean by remember less? An operational definition for remembering less could be we can compare the number of words correctly recalled after a normal night's sleep with that of a shortened night's sleep. So we're quantifying the number of words and the hours of sleep from a normal night and a shortened night. So why is this important? Well, if we specifically define what we mean by sleep loss or caffeine or smiling, then we are able to really understand what that is and we're able to replicate it. So we can only repeat the experiment precisely as it was conducted the first time. If we're not exact and we're not specific, then there's no way we're going to be able to replicate the experiment. So let's think about operational definitions. Plants that are exposed to music show increased growth. What type of music will you play? How loud will you play the music? How long will the plants be exposed to music? What type of plants will you use? How will you measure growth? How often will you take your measurements? These types of questions are so important to creating your operational definition so that you can create an experiment. All right, how can we test hypotheses and refine theories? There's 3 main ways: descriptive methods, correlational methods, and experimental methods. 3 types of descriptive methods are case studies, naturalistic observation, and surveys and interviews. Case study is a descriptive technique in which one individual or group is studied in depth in the hope of revealing universal principles. How do psychologists use case studies to observe and describe behavior? They can observe one individual or one group. And strengths and limitations. Strengths, it allows for the examination of rare or unusual behavior and provides a large amount of qualitative data. Qualitative meaning anything but numbers, things you can, you think your 5 senses when you think qualitative. And they suggest directions for further study. Some limitations, they're atypical, not they, but atypical case studies, so case studies that are not normal, can be misleading. Results from one study may not be generalizable to the larger group, and they cannot determine cause and effect. And we're gonna take a deep look at a lot of different types of specific case studies later on in this unit. What is naturalistic observation? It is a descriptive technique of observing and recording behavior in naturally occurring situations without trying to manipulate or control the situation. So again, I told you earlier that a lot of these new terms define themselves. Naturalistic observation, observing naturally occurring situations. So there you go, it's defined itself already. How do psychologists use the naturalistic observation method to observe and describe behavior? Well, we've got the famous study of watching chimpanzees in the jungle. Just by watching Jane Goodall, just by watching the chimpanzees in the jungle, she was able to learn so much about their behaviors. So how else do psychologists use the naturalistic observation method to observe and describe behavior? Psychologists Mel and Pennebaker attached voice recorders to 79 college students to listen in on their day-to-day conversations. And you might be like, what? Well, there's something called ethics in research, and we're going to get to that later. So they knew they had voice recorders for this study. This wasn't, done without their knowledge. How can naturalistic observation method describe behavior? So you can look at trends over time. So here we're looking at counting positive and negative words in 504 million and Twitter messages from 84 countries. So we've got positive tweets were highest late Saturday night, positive tweets were lowest Tuesday afternoon, positive words in the tweets. So you can look by graphing and looking at trends over time. Strengths and limitations. Subjects behave normally outside of a lab setting. That's a big time strength. They're in their normal setting. And another strength is the data collection is unobtrusive. It does not disturb the subject. Limitations, the independent variable cannot be isolated, and we'll get to what that is in a minute. Cannot determine cause and effect, and the observations themselves by the researcher might be subjective. Okay, a survey is a descriptive technique for obtaining the self-reported attitudes or behaviors of a group, is usually by questioning a representative or random sample of the group. Psychologists use this to observe and describe behaviors in many different ways. Here are a few examples. Half of all Americans reported experiencing more happiness and enjoyment than worry and stress on the previous day. 1 in 5 people across 22 countries report believing that alien beings have come to Earth and now walk among us disguised as humans. And 68% of all humans, that's about 5 billion, say that religion is important in their daily lives. Strengths and limitations to surveys. You're able to take a quick pulse of people's beliefs and able to include many different cases, but you have response bias. Wording of your survey can skew the outcomes, and acquiring a random sample is usually pretty hard with a survey, and it cannot determine cause and effect. So which of the two phrases below would you be in favor of supporting? Gun safety laws or gun control laws? Aid to the needy or welfare? Revenue enhancers or taxes? So let's look at the wording. Did you support aid to the needy? Do you support welfare? Turns out that more people respond favorably to the first statement than the second. The way we word our survey has significant effects on the responses, even though those things that we just looked at in the last slide mean the same thing. So we've also got to consider sampling bias. Survey finds 94% of people support federal funding of the space program. What questions should you ask? Where was the survey conducted? Who was in the sample? Is survey location a possible problem? Survey finds 94% of people support federal funding of the space program, but where was the survey conducted? How could each of these survey locations change the results? What if it were conducted in Washington, D.C.? What if it were conducted at a screening of Star Wars, in a small town in Iowa, at a political event? Those people in those different locations would totally skew the results of the survey. Why is the survey population a possible problem? Again, look at the different types of populations: naval aviators, students at a technical college, prison inmates, and teenagers. Depending on who you're surveying, you're going to also have different responses. So, a representative sample. If you wanted to survey students at your school, how would you choose whom to survey? Representative sample has the same distribution of demographic qualities in it as the whole population as a whole. So if the student population at the school is 25% Hispanic students, 30% Asian, 35% African American, and 10% Caucasian, your sample should reflect those percentages. If your school is 50% female and 50% male, equal numbers of both sexes should be represented in your sample as well. What's a population and a random sample? So population is all those in a group being studied from which samples can be drawn. A random sample is a sample that fairly represents the population because each member has an equal chance of inclusion. So if you wanted to survey high school students about drug use, how would you identify your population? How could you create a random sample? These are questions to think about. We've got two types of research as well. We've got cross-sectional and longitudinal. These words, again, they define themselves. Cross-sectional compares different age groups at one time. Most common type and advantage, it's more efficient to do different age groups at one time. Disadvantage, it's hard to measure and determine cause and effect. Longitudinal has the word long in it, so it studies the same group of people over a long period of time. These are more rare than cross-sectional. It's a rich source of data, which is an advantage, and a disadvantage, it's expensive, time-consuming, and hard to conduct. It's expensive and hard to conduct and time-consuming because it's studying the same group of people over a long period of time. So the reason that it's more rare is because of the disadvantages. Last part of this lesson, and I know we're going over the 20 minutes, that will happen pretty rarely in your lessons, so thank you for your patience. How can experiments establish cause and effect? Experiments enable researchers to isolate the effects of one or more factors in two ways. One, by manipulating the factors of interest, and two, by holding constant or controlling other factors. What's an example of an experiment that shows cause and effect? Does breastfeeding lead to smarter children? The cause would be breastfeeding, the effect would be smarter children. How are groups assigned? There are two groups, experimental group and a control group. This is all review from science, but we are going to be applying it to psychology. The subjects receiving the treatment are the experimental group, and the subjects not receiving the treatment are the control group. So the definitions of those two things are exactly the same as you've learned in any other science class. So, example, pediatricians promoted breastfeeding to the mothers in their group, and pediatricians provided normal care but did not promote breastfeeding in the control group. So, how was the experiment conducted? In the experimental group, at 3 months of age, 43% of the babies were breastfed, and in the control group, at 3 months of age, only 6% of the babies were breastfed. What were the results? At age 6, when nearly 14,000 of the children were restudied, those who had been in the breastfeeding promotion experimental group had intelligence test scores averaging 6 points higher than their control condition counterparts. What is random assignment? Assigning participants to experimental and control groups by chance, thus minimizing pre-existing differences between the groups. So, why does that help establish cause and effect? So, back to the breastfeeding. What if all babies in the experimental group shared one specific trait that influenced intelligence? So, if so, then our results would be skewed. So in order to control confounding variables, experimenters randomly assign subjects to the experimental and control group. Difference between random sampling and random assignment. Random sampling, you choose a representative sample of the population being studied. Random assignment, you assign participants to the experimental or control group. That minimizes pre-existing differences between the two groups. Okay, so now how does using a blind procedure help establish cause and effect? You've all heard of blind procedures before, I'm sure, from the news at some point or another in dealing with like the placebo effect. So we're going to go over single blind and double blind. In single blind, the participants in the study are uninformed about the treatment, if any, that they are receiving. Controls for subject response, bias, and placebo effect. So doing a single blind means that you are controlling subject response bias and placebo effect. A double blind, the participants and the researcher are uninformed about which group receives the treatment and which does not. The only difference is in single, the participants are uninformed, and with double, the participants and the researcher are uninformed. And what that does for double blind is it controls for experimenter and subject bias, as well as the placebo effect. So what is the placebo effect? Well, it's an inert treatment like a pill without any medicine inside. The placebo effect causes experimental results simply from expectations or assumptions that medication is being taken. So here in this cartoon, I don't think it's going to work. Will it still work? So it's like giving participants a sugar pill and telling them that it will cure something else. And then people thinking that that pill actually had an impact when really it was just a sugar pill. That's a common example of placebo effect. So let's look at the research on it. Athletes have run faster when given a supposed performance enhancing drug, a fake performance enhancing drug, but yet ran faster. Decaf coffee drinkers have reported increased vigor and alertness when they thought their decaf had caffeine in it. So really, here's a coffee. You're telling someone it has caffeine in it, but really it doesn't. And yet they thought that they had more energy. People have felt better after receiving a phony mood enhancing drug. So maybe I'm going to give everybody in class a Tic Tac and tell you that it's going to make you all laugh. And then everybody starts laughing. Is it the result of the Tic Tac or the result of me telling you that the Tic Tac is going to do something to you? I'm not going to do that, but it would be funny. So what's the difference between an independent and dependent variable? The independent variable, again, these are not any different from what you've learned in science in the past. It's in the experiment the factor that's manipulated, the variable whose effect is being studied. It is only ever given to the experimental group. The dependent variable, that's what's being measured. That's the outcome. That's the variable that might change when the independent variable is manipulated. The dependent variable is measured in both groups. And when I say groups, I mean experimental group and control group. Exam tip, this is a biggie. The identification of the independent variable and the dependent variables is the single most likely concept to be tested on the AP exam. Experiments are critical to psychology, and independent and dependent variables are critical to experiments. So when you are dealing with independent and dependent variables, remember to use operational definitions to quantify your variables. And this is specific to the free response section of the exam. Okay, and we'll do lots of practice, so don't stress out. All right, so I mentioned a confounding variable earlier, and so I want to define it now. A confounding variable is a factor other than the factor being studied that might influence a study's results. So the key is that some unique factor must be present in one of the groups, but not the other. A variable cannot be confounding if it occurs to the same degree in both groups. Random assignment is one method used to prevent confounding variables. So what are some examples of confounding variables that might impact a study? Age, intelligence level, ethnicity, sex, political beliefs. These are some things that are going to impact your experiments. So using random assignment is going to lessen the impact that confounding variables have. So the last slide, what's experimental validity? Well, it's the extent to which a test or experiment measures or predicts what it's supposed to. So for instance, if you take a driving test and pass it, we should expect to see accurate driving skills from you. The driving test would be considered a valid measure of your ability to drive. Woo, thanks for hanging in there, y'all. Again, that was a foundational lesson with a lot of review in it as far as the experimental design and scientific method. So just remember that. And we're going to do some practice in class. So remember that. And I can't wait to see you guys. Bye.